Hey, it's Mr. Allred, and I want to work some initial value problems. So in these cases, remember what we did was we took an antiderivative, which would give us a plus c, and then we had some extra information that would allow us to find c. So I'm going to pull some problems from the book. Let's see what we got here. We'll start with something fairly simple. This is on page 239. And it's number 78. So the way the book gives it to us, it gives us ds dt, and that's going to be equal to the cosine of t plus the sine of t. So they're giving us a derivative here. ds dt is the same thing as s prime. So more or less, we can rewrite this thing as the integral of cosine of t plus sine of t dt, okay, if we want to integrate it. So going through that, just to make sure you understand what's happening there, they also give us another piece of information that we're going to use in a little bit, so I better write it before we forget about it, and that's that when we find the antiderivative s, since this is ds, that when we plug in pi, we will get 1. So we're going to integrate our cosine plus sine and see what we get. So the antiderivative of cosine is negative sine. Excuse me, no it's not. It's regular sine. So sine t. And then the antiderivative of sine is negative cosine. And in that case we'll have a plus c. So this is our integration of s prime, so now this is s. Okay. So that's our function. So now we can use this one piece of information over here. We've taken an antiderivative, but let's plug in what we've got. So it's telling us that when t is pi, that s is going to be 1, because it has an input-output combination from the function. So let's plug that in and see if we can get to c. So 1 equals the sine of pi minus the cosine of pi, and then plus c. So we have everything but c right now. So we do have to know that the sine of pi is 0, and the cosine of pi is negative 1. So that's going to come down to 0 and then a positive 1 plus c. So in this case, c equals 0. Wow, that was kind of boring. But if we take that piece of information and the fact that we found the antiderivative function, for this particular scenario, we'll know that the antiderivative is just sine of t minus cosine of t, plus 0, which we don't have to write. Alright, so let's do another one here. Let's hope we find one a little bit more interesting, but still doable. So this one here is going to be page 239 again, and I'm going to pick number 75 for some reason. So let's see here. The problem out of the book is dy dx. And it's going to be equal to 3 times x to the negative 2/3. And the initial value they give me is y of negative 1 equals negative 5. So they give me a y prime function, a derivative, and they're asking me to find the y function, and they give me information to narrow it down to a specific c value. Alright, so I'm going to rewrite this as an integral. So the integration of 3x to the negative 2/3 dx. So I'm going to reverse my power rule. So I've got 3 out here. X, the exponent is going to go up to 1/3. And if I divide by 1/3, I don't like the way that looks. If I divide by 1/3, it's going to be multiplying by 3. So let's just go ahead and do it that way. and then there'll be a plus c, and that's my y function, but let's clean it up just a little bit. So y equals 9x to the 1/3 plus c. So we divide by 1/3, so it ends up multiplying by 3. So in this case, we're going to go back in and we're going to take our x value, which will be -1, plug it in, our y value, which is -5, plug it in, and see what we get. So we get -5 equals 9 times the cube root of -1. So that's going to give me -9, and then plus c. And I'm running out of room, but that will tell me c equals 4 when I get it by itself. So let's pull that up here along with my y function and finish it out. So y will be 9 times x to the 1/3 plus 4. So we should be able to plug in our -1 for x and get -5 back. That's what the initial value up here tells me. And I should be able to take the derivative of the function and get the derivative function I have here. All right, let's do another one. All right, so page 239 again. Let's do a second derivative problem. It might help you get used to the notation even if we don't use it a lot in class. But I have here number 86. The notation will look a little bit different. So it's d2s over dt squared. So d2 here means the second derivative twice of s function. So what we're trying to integrate to eventually is an s function. And in both times we took the derivative with respect to t. So the function they give me there is 3/8t. And then they give me two pieces of information. They give me ds dt when t equals 4 to be 3. That's a fancy way of saying that s prime of 4 equals 3. So the first derivative of 4 is 3. And then they also give me in a little bit better notation that the actual function value s of 4 equals 4. So let's come back over here and work our magic. So the first thing we got to do is integrate the first time. So we're going to integrate, and when we do that, that's going to give us the s prime. We're going to integrate 3/8t dt, and that's going to give us the first derivative since we're actually integrating the second derivative. So that'll go up to t squared, and I'll divide by the 2, so it'll be 3/16 plus c, and that'll be the s prime. So I can come back with these values, and from my first derivative, initial value here, I know that when t is 4, the output is 3. So that will give me 3 equals 4 squared is 16, so that cancels out with the 16 on the bottom. So 3 equals 3 plus c, so c equals 0. So the first derivative after I do the initial value and find the c is just 3/16 t squared. Okay, so I found the first derivative. Next, I want to integrate that. And when I integrate the first derivative, I will get the actual s function. Okay, so when I integrated the second derivative, I get the first derivative. When I integrate the first derivative, I get the original s function that I'm really looking for. So in this case, s will look like, that'll go up to a cube. And when I divide by the cube, I'll have 3 over 3 times 16, so it'll be 1/16 t cubed, and that'll be plus c. Let's try and make it look a little bit more attractive. So what I know this time is, let's see, let's use, I think we can pull some other colors in. It's a rainbow. I don't know what this pen does. I'll stay away from it. But here we'll use the 4. So when T is 4, S is 4. So plugging that in, we'll have 4 equals 1/16, and 4 cubed is 64. That'd be plus C. So basically 4 plus equals 4 plus C, so C equals 0. So this is the least exciting problem of all, because eventually all the initial values were 0, but we get the S equals, by plugging this C value back in, 1/16 T cubed. So we took this guy and plugged it in there. I didn't mean to get too close there. And I took this guy and plugged him in here. Alright, that's probably enough for this video, and we'll find some more in a little bit.